welcome back to my channel. In this today's session we are going to be deriving an expression for de Broglie's wavelength for a particle wave. Before going to this, we are going to be understanding what do you mean by particle wave. So according to the Einstein, the reflection, whenever the light is passing from one medium to another medium, the light will be bouncing back for the same medium. So Einstein will be saying that the light which is moving from one medium to another medium by bouncing back will be not moving like a straight line, it will be moving like a wave shape. And he defined that light is a wave. And similarly, he took a reference of refraction. What is a refraction? Whenever the light travels from one medium to another medium, the light appears to be bent. For this also he defined that it is moving not in the straight path, it is moving like a wave path. And similarly, he has given the same expression for diffraction also. What was the diffraction? Whenever the light is opposed with a sharp edge, the light will be split into two. Here also he told that the light will be not moving in a straight path, it will be moving like a wave. According to the Einstein, this three debate told that the light is having a nature of wave nature. Similarly, there is another scientist called as Planck's. He will be debating by using a photoelectric effect. What is a photoelectric effect? You know that it is an energy packet which is coming and hitting the surface layer of the metal, and the electrons at the surface area will be ejected outside, and this phenomena is called as photoelectric effect. And he told that whatever the light which is falling on the surface layer of the metal, it is not actually the wave nature, it is a particle nature. Since it is a particle nature, that's why one particle is coming and hitting another one, so that's why one particle is coming out. And he also given an example of Compton effect and as well as a Zeeman effect also, and he proved that the light is not a particle nature, light is not a wave nature, light is a particle nature. So after this, the person called de Broglie, he came and he solved this issue. He told that so light will be having a dual nature, that is particle nature as well as wave nature togetherly. So this together nature we will be calling it as a particle wave. It is a new wave which has been given birth where it has a both nature, particle nature and wave nature. So this is the newest one. So since it is a wave, for this there is a wavelength. So that is wavelength is named as a de Broglie wavelength. Okay, so for this wave we are going to be deriving an expression for a de Broglie's wavelength. For the wave is particle wave. So how to do this one? So first we will be taking the energy equation of Einstein. Einstein's energy equation is given by E is equal to mc square. We are taking a fundamental equation, E is equal to mc square, take it as equation number 1. Got it? Similarly, Planck's also given an energy equation is given by E is equal to h nu. So h stands for Planck's constant, nu is a frequency. So if I write this as a frequency can be written as mu is equal to c by lambda. So what do you mean by c? C is the speed of light and lambda is the wavelength. So we will be considering it as a equation number 2. Now according to the particle wave nature, So, since the particle wave nature for any light or a subatomic particles like electron, proton or neutron, so we will be having a dual nature, which is the nature particle and wave togetherly. So, as situation demands, the particle nature will be demanding, or if the situation demands, the wave nature will be coming into the existence. So, particle wave nature both are same, means they are same togetherly. So that's why what I will be doing, equation 1 and equation 2 will be equated, means we will be using equation 1 and equation 2, and we will be equating as mc square is equal to hc by lambda. Now here c and c square will be cancelling, and I will be rearranging lambda is equal to h by mc. According to this, you know that p is equal to momentum. So mass into velocity will be a formula for the momentum. So I will be applying mass, and this is a velocity of a light. So if you multiply together, that will be giving a value of momentum. So h by p will be the formula. So the lambda represents a de Broglie's wavelength, and h represents a Planck's constant, and p represents the momentum of a particle. So this will be a formula for the de Broglie's wavelength. So this formula can be written in multiple ways also. So take it as equation number 3, where lambda can be written as h mass into velocity. This is a second type which we can write it as an equation. And one more equation by considering kinetic energy. You know kinetic energy, what is the kinetic energy? Of mv square. So if I want to replace this one, I can replace it as a p square divided by 2m. So how come I can replace? You know momentum value is mass into velocity, mass square and velocity square 2m. Mass get cancels, the value is half mv square. Both are same. So in spite of taking as half mv square, I will be taking this as a p square divided by 2m. Now kinetic energy will be taken as E. If I rearrange, p square is equal to 2m E. So I don't want a square here, I will be applying root on both sides, then the value will be 2m E. So apply this value in the equation 3. Equation 5, apply equation 5 in equation 3. So what will be the lambda value? In spite of a p value, we will be replacing it with 2m E. So this is the another type of a formula which represents a de Broglie's wavelength. Take it as equation number 6, right?